go through my presentation. It basically gets into the actual image rendering process of creating natal charts, which is actually significantly more difficult than a lot of like traditional NFT stuff. So I kind of wanted to give people a sense of what that's about. If you have like a comment or a question, just like throw it out there as I'm presenting. And honestly, about halfway through, it gets pretty technical. A lot of NFT stuff is images that are created before they're actually minted, and it's actually a pretty straightforward process. But what we're doing with natal charts is actually more complex and takes a lot more time. So just so people kind of understand that process, that's what I'm getting into. Just because I assumed when I talk about like custom rendering algorithms, I assume that people know what I'm talking about, but I realize I'm thinking about like a programming audience, and I realize a lot of people don't understand what image rendering is. So I'm going to kind of get into that and why what we're doing with natal charts and creating natal chart NFTs is actually more difficult than what a lot of people are doing with NFTs. Okay, so how are NFT collections generated? So like 1 out of 1 NFTs, or like someone creates an image, saves it to a database, and like connects an NFT to it. But in terms of like these 10K NFT projects, the way they're generally done, like here is an example of CryptoPunks, is that, again, ask me any questions if you have questions at any time. So there's like a bunch of layers. There's a face, there's like all these features like hats and glasses and blah, 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 blah. And all these like layers are randomly selected and put together. So like no one, basically what I'm saying is like no one creates 10K, 10,000 CryptoPunks. There's an algorithm that generates each of these. So here's some like pseudocode. So basically this isn't real code, but this just shows the procedure. So one layer, like someone selects a face, someone selects a hat, blah, 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 select some feature, and then all those things are pasted together. And then I assume that there's some check for uniqueness just to make sure that there's not like duplicate images in the collection. And then that's added to the collection. So this is like a very high level rough algorithm for what a generation algorithm looks like for most 10K NFT collections. So ask me any questions if you don't have a programming background. But what I'm trying to show is that this is relatively simple to what we're doing. Does that, any questions? So like you randomly select a face, you randomly select
looks
a hat.
a bit technical. Do you mind just quickly rerunning that? I'm so sorry.
Yeah. So basically we're literally on the second. I'm basically explaining like what we're doing with generating natal charts is more difficult than what your regular generative NFT collection is.
Yeah.
I'm actually glad you're here because you've had some experience with like Milady's kind of derivative collections, right?
Yeah, I've done a number of NFT generations before. I think I also originally brought up like, you know, what was unique about this. Like I'm aware of what we need to do. That's
yeah. Basically, I'm kind of I use the example of CryptoPunks because it was literally the only image I could get on Google Images, just to give people like a visual sense. But this is like pseudocode. You select a random face, you select a random hat, you select random glasses, blah blah blah. You paste them together. You have some check to make sure it's unique, and you add it to the collection. So no one's drawing 10K images. There's like an algorithm that.
Yeah, understood. It's like each component fits together, make sure it hasn't happened again, then.
Yeah. And any issues with my pseudocode, Scott?
No, that's right.
Okay. All right. So this is just like again, I think I'm not complaining. I'm saying that what we're doing is more difficult and is actually like more impressive if we actually be able to execute it. But this is like what your average 10K PFP collection does. It's not simple. There are nuances, but essentially this is it. This is the procedure. Okay. So why is generating natal charts different and more difficult? Does anyone know?
Yeah, because
it's not randomly choosing components. It's like depends on the person's own innate already present components.
Exactly.
Yeah.
So here I just like literally made a little artistic collection of all the layers. These are all the layers we use to generate a natal chart. So it's like we're not randomly shoving this stuff together in a PNG. Like this has to be put in a very specific position, depending on people's natal charts.
Right.
Okay.
Yeah, I think what you would do is you would do like a rotation.
Yeah.
Based on, yeah.
We're getting into that. Okay. So layer position. Okay, so these are all the layers. So like when you see the final image, there's actually like something like 20 layers that goes into it. And it's just a question of like, how do you position those layers and how do you resize them, et cetera, et cetera. Okay, so layer positioning. So how do we go from, so this is just like a visual example. So we have a Mars layer, we have a natal chart, and then we have something like, I think I picked a stellium here, but we have like a time of birth and a location. So we have to convert all of this. Do you guys see my cursor? Is that like visible? Oh, okay. So we have to convert all of this information into something that looks like on the right. Okay.
Well, I mean, okay. You don't just mean like that sector. Like you mean it's translating into the planets.
Say that again.
I wasn't sure if there was something wrong with what you said define to disagree about. I just was clarifying.
Oh, no. I was just basically saying, like, in terms of, again, maybe I keep using the term image rendering, assuming people know what I mean. But like, basically, I have to take a Mars layer, this natal, whatever you call this, like the
Right.
whatever.
Yeah.
And plus someone's birth information and convert it into a specific position that Mars
Right.
to a specific position. Again, I'm just getting into the thing, like this isn't just randomly like putting with
is that for these apps that like I'm using on Web 2, is it just as difficult like for them to have gotten to that? Got it.
Yes. So this isn't even a Web3 stuff. This is literally just how do you make this picture?
Right.
Guys,
Oh, hey, Marco. I'm only into like slide 3. I'm basically just explaining like how we create those natal charts based on someone's birth information and how it's generally more difficult than like what's typically done in 10K PFP collections. Okay, so we have to take this layer, combine it with someone's birth information, and convert it into something that's actually visually accurate. Okay, so Marin, you're probably familiar with this. An ephemeris is a book that contains planetary positions for each day of the year. So astrologers actually had to do, back in the day, they actually had to do a lot of like math and shit. But luckily we have programs that do this stuff. And I actually learned this, I didn't know this before, but something called Swiss ephemeris is like the standard for like APIs for astrology. And this is maintained by the same people that do astro.com. I'm sure Marin is familiar with them. They do like really good articles and stuff like this is like, I took a quick look at this and this is extremely sophisticated. So luckily I don't have to do any of this computation myself. There's a function that tells me exactly the planet position. So I give it a date, a time zone, and it tells me the position of the planet. That doesn't fully actually simplify things, but luckily I don't have to deal with ephemerises. There's an API for this. So that's why I got to this screen. So this simplifies this lower portion. So I get a degree. So luckily this API gives me a degree, so I don't have to compute this. So now I have a Mars layer, a whatever fucking zodiac ring, and a degree. But that still doesn't significantly simplify things into computing it into this position over here. So how do we do that? Okay. Gets into a little bit of geometry, but basically you essentially have to solve, you have a degree, you have a radius, and you have to solve for where do we place. So I know the degree, how do I figure out where do I place it on the ring? So high level, this is relatively simple high school geometry. You take, given a radius, given a degree, you can figure out the XY position. However, and I apologize, like this is meant for a technical audience, but I'll try to kind of keep it high level. This also depends on the ascendant, because depending on the ascendant, where 0 degree Arius is changes on the actual image. So I have to take this actual mathematical formula and consider ascendant, the actual origins, the actual like center of the image, which isn't 0, 0. It's something different when you deal with images. Okay, but I don't want to get into if anyone wants to know the details, ask me. But I have to take.
No, I think I get what you're like. I don't read real code, but I can look at this and be like, yeah, okay, I understand how you're going to need to calculate the ascendant, the degree from 0 Aries, like all of that. Like, yeah.
So basically what I'm saying is like, there's a high level formula that's like high school geometry, but in order to actually implement it, there's like a lot of other things I have to take into consideration. So this simple formula gets a lot more complicated. And even though this is 10 lines of code, this is literally like 1 to 2 hours of sitting on a piece of paper and like writing out math equations to figure out like where to put Mars on the chart. Again, I'm not complaining. I actually enjoy this stuff. I just want people to get a sense of like, this isn't trivial. Like there's actually like a lot of complexity here that has to be taken into consideration. Again, if anyone wants any details, this is more meant for a technical audience, but if you want any details, let me know. Okay. So, and then there's, even after you figure out the position, I mean, this is technically correct. It's sort of in the same position, but like you have to take into consideration the actual size of the image, the size of the layers, blah, 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 because this is technically correct in terms of like degrees, but like this is technically in the correct position in terms of degrees, but you have to consider the actual image size. So this is where like good engineering practice comes into place, because if Marco, ask me any questions at any time because I'm covering a lot of details, but if Marco sends me a higher resolution background image, I don't want to have to change all of my code. Like, so I didn't want to make my code in terms of pixels, because if I define everything in terms of pixels, if Marco sends me a high resolution image, I have to change all my code. So everything is defined in terms of the height of the background image. So if Marco sends me a higher resolution image, it doesn't change any of my code. So I had to actually, so this is where good engineering practice comes into place, because I want to reduce the degrees of freedom. If anything changes, if any of the layers change, if any of the resolutions change, I don't want any of the code to change. So basically all of these things, like the radius of the planet, like the size of the planet, the distance it is from the center, all of that is defined in terms of the size of the background image in terms of pixels. So it's like, I don't know if that makes sense, but it's like if anything changes, I don't want to have to change my code. So all of these like hard-coded things, like how big is the planet, how far it is from the center, all that is defined in terms of the size of the image. Just so like I said, if I get a higher resolution image, none of my code has to change. I'm just showing off my software engineering skills. Okay, so that is like, this is the most basic stuff in order to get a planet in the correct position. That's like, this is the most basic stuff, and I had this done like a month ago. So we get, in order to actually like, now I'm getting into custom image rendering. So these are like custom algorithms to get the image to actually look good. So you won't understand until you see the next image. Like this is what happens if you have a stellium. And like if you're not interested in your final product, sure, you could ship this and you could make people pay for an NFT that looks like this. But I imagine that we're a company that doesn't want to release shit. So this isn't acceptable. Do we all agree? So again, this is correct. This is someone's stellium in Capricorn. That's what it looks like. You have everything kind of around 20 degrees, but you don't want to display something like this because it looks like shit. So and I apologize when I kept saying that I'm writing custom rendering algorithms. I assume people know what that meant, but I realized that it's something that only certain types of software engineers would understand, because image rendering is notoriously difficult. It's typically used in the context of like, how do you render a 3D image, which is much more difficult. But a lot of the same principles apply, where you literally have to write specific algorithms to make an image look like. So you have an image you have a description of what the image looks like, and you have a description of what the input data looks like. And you have to kind of do that conversion. I realize this is a really high level stuff, but I want to kind of give a sense that this really isn't easy. So I had to write a specific algorithm for how to spread out these planets and make them visually not look like this. Yeah, so I created an algorithm called spread planets. Okay, this gets really technical, so I don't know how much I want to get into it, but I was also really impressed because my algorithm was pretty complicated, and I had I typed in my algorithm, or I copy and pasted my algorithm into ChatGPT, and it wrote a doc string that was mostly correct. I had to do some edits, but I was actually really impressed. I don't know if I want to entirely get into it, but basically you have to write an algorithm that detects clumps. It literally goes around the circle and detects clumps and then spreads those clumps. And it involves a lot of like mathematical geometry. Like it's not something like you don't type into like a computer like draw an image. Like you have to describe the geometry in terms of mathematical equations in order to get it to render properly. And if anyone, the code's public, so anyone could take a look at it. I don't know if I want to get into too many details. So just to show you like some of the like details, like I had to, so after like generating a bunch of images, I realized I had to change my algorithm, because if you simply spread out the images, so here's a stellium and Aquarius. If I use my naive algorithm, it's not centered into Aquarius. It starts moving into Capricorn. And it looks kind of ugly. And this is something that you literally wouldn't know unless you did astrology. The fact that all these things are kind of creeping into Capricorn, it doesn't look good. So I had to add an extra thing that says that if there's a minimum of 5 planets in a stellium, it has to be centered in Aquarius. I don't know if anyone sees what's going on here, but like if I use my naive algorithm, it kind of bleeds into Capricorn. But if I actually center it to Aquarius, it sort of has a much nicer view of where the
I see on my software AstroGold, it does the same thing where if necessary, the house will do a thing where it goes out like
exactly.
Yeah, which it's fine that it doesn't, because it's clear that it's Aquarius. So yeah.
I was actually that's why I kept asking, if you remember a few weeks ago, I'm like, send me dates with stelliums, because these are in software what are called edge cases. Like most of the time my naive algorithm works correctly, but in extreme situations where you have stelliums, like extreme stelliums like this, it's not going to render properly. So you have to write algorithms specifically for this. So basically because of like the input you gave me, I had to actually do a couple of experiments to actually get it to change my algorithm to get it to render properly. And trust me, like I didn't even include the code. You can take a look at it. It's not trivial. It's like, it's something that you literally have to know math, significant amount of like math to be able to like do this. And I say that because I don't mean that arrogantly, but I feel like because humans are so, it's so easy for humans to see images and understand images. It's really hard for computers to understand images and to generate images. You have to tell them everything, degrees, sine, cosine, blah, blah, blah. Like, I'm not trying to be pretentious here. I'm just saying that like getting computers to generate images is not trivial, and to get them to generate things correctly is involves a lot of math. So this works quite well, and it took me like probably quite a bit of time to do to have it generate correctly. So the thing is, like most people that are going to generate a chart aren't going to have this kind of a stellium, but like if you're going to make people pay for an NFT that literally is generated one time, it has to be perfect, right? Like you don't want to generate something that someone pays for and it looks like shit. So like the chances are that someone's gonna ask for a chart that has this is very little, but still like you kind of want to check for this situation. Okay, so this is getting into technical details, but like there's part of this function, the first part of this function is to check if there are clumps. So there's like a whole algorithm here that checks if there's a clump of planets. And trust me, this is not trivial. And if any programmers here want to take a look and tell me that they could have done it any better or any more efficiently, please go ahead and do so, because this is not easy. Just to go around the circle and to detect if there's any clumps. That's difficult enough. Again, a bit of like stuff for programmers, but I realized my original, after testing it, I realized my original algorithm wasn't correct, and that you actually have to detect clumps by doing a clockwise rotation and also do it counterclockwise. It's something that took me a little while to figure out, but I even asked ChatGPT to look at my code and tell me why you need to do forward and backward pass, and it didn't even know the correct answer. So in case anyone is actually interested, this is sort of like an example of why. I won't get into the details, but like if anyone wants to actually come up with an example, but there's a reason why you need to do a forward and backward pass. And here's like a little bit of an example of why you need to do that. Okay. So that gets it, that this is actually probably the most complicated part of the whole image rendering process, is declumping planets that might be overlapping in order to render it properly. Okay. More custom image rendering. So this is something that I've been doing like in the last 2 days. So can anyone tell me why? So the information here is correct, but the image looks wrong. So can anyone tell me why the stuff on the left looks better than the stuff on the right? Or am I the only one? I feel like maybe the designer can tell.
The degrees are weirdly placed. Like the spacing is just weird on the right one.
Yeah. Yeah. Like I said, maybe it's like a thing a designer can tell better. So yeah, you're right. So
it follows the rule of thirds, actually, in like photography and everything. So design wise, it is aesthetically more pleasing to the eyes.
Yeah, yeah. So the ones on the left kind of, maybe I should have done a bigger screenshot, but these are actually aligned, as you can tell, whereas these ones are a little bit off. And can anyone tell me why?
This might not be the formal way of saying it, but like they're all going into the center. Like they're just like, they all, and then these, I don't even know what's happening there, but they're just skewed.
Yes, that's correct. But do you know why though? I'm not putting you on the spot.
No, I understand. No, I don't know the code why.
The way that these layers, like in terms of the planet layers, are positioned is that the center of the image is positioned at a particular degree. So the thing is with the sun, the center of the sun is literally like the visual center, is this dot. The center of the image, because these images are squares, like the actual image is a square, a PNG. So like when it's placed, when the layer is positioned on the underlying background image, it's positioned based on the center of the image, like literally the pixel center of the image. So because the moon is a circle and the sun is a circle, the visual center of the image is like the actual center of the layer. I'm not describing myself very well. Okay, it'll make more sense here. The reason why this looks off is, again, the designer would know better, but the visual center of Mars is the center of this circle. That's the visual like center of gravity, is the center of the circle. But because the Mars PNG is literally a square, the center is around here. Yeah? So like this positions it based off of like the actual center of the PNG. But if it were to center based on the center of gravity, the visual center of gravity, it would be the center of the circle. So if it were to do that, it would shift it a little bit right, and it would actually look correct. Same with Venus. Like the center of the PNG is somewhere around here, but the visual kind of center of gravity is here in the center of. So like I haven't done this yet, but I know how to do it. I literally have to go through every single planet image and define the center.
Wanted to ask, and define the center, yes, by yourself.
What is that called? What is that called in visual, like in terms of graphics? Is it?
Don't have the. I don't know if there is a.
Yeah, I've been calling it like. yeah, I've been calling it like the visual center of gravity because you want the circle to be the center.
That's fully legit.
Yeah, yeah.
Fully legit.
So yeah, so again, I'm not complaining. I like difficult problems. I have fun solving difficult problems, but it's one of those things that you don't really think about until you actually have to generate an image. So I like, again, I'm not complaining, but I have to go through every single one of these planet images and define the center of visual gravity in order for it to align the way it does. Because with sun, the visual center of gravity is the center of the image. With the moon, the visual center of gravity is the center of the image. But with Mars and Venus, I have to redefine it in order for when it's pasted onto the underlying image, it looks good. And
Well
I
done,
also
Sasha. Honestly, because you know when you are a designer, it's like it's easier for you because you are just placing there. I don't fucking care about the math, but for you, then it's a challenge and a tough
exactly.
one.
Because I have to deal with someone's going to write
Yes.
in any possible date, so it has to be
Yes.
correct for every single possible configuration.
Well done. Yes.
Thank you. But again, I don't want to be like arrogant or pretentious, but it's something like you don't realize because humans are so good with our eyes are really good, and we don't realize how hard it is to tell a computer to do this stuff. And I also want to give a sense that like your average engineer isn't going to care. Like I really care about creating something good. So like that's why I kept testing and testing and testing to find these cases where I'm like something is off and the algorithm needs to be changed. So this is something that still needs to be implemented. It'll probably take a few hours, but it's something that makes a difference into someone that buys an NFT and buys a quality NFT.
Yeah, no wonder now that there's like no major, like it's literally Astrodienst who owns both Solar Fire and Astro Gold. They're the only person that's really ever done this. So no wonder you don't see this coming up again and again because like it's such an undertaking.
Yeah, it is.
It's also a very niche like subject. I've been trying to find references and there's nothing on this ever.
Yeah. So again, I genuinely, I have been enjoying writing all this stuff. Like I like writing this stuff. It's fun for me, but I just do want to get a sense of if I say something, I'm not trying to put Chelsea on the spot, but when she told me to generate natal charts, I was like, just doing the generation code is going to take a month. And like, I don't think
this is helpful to understand. Like I mean, I knew it would be complicated because there's so many different things. I wouldn't have the idea of like, oh, you have to make sure that like I'm thinking of it as being buoyant. Like each symbol has to be properly like buoyant in a way that is like not tilted. That's the way I'm thinking of it. Like I wouldn't have known that. So that like this leads me to have respect for any engineers ever working on astrology.
Yeah. So like I said, this is fun. I've had a lot of fun working on this, but it takes a lot of time and it takes a lot of time to do it correctly and to do it like, which I assume everyone wants something that's of high quality. So again, so the hardest thing I had to do was the declumping thing. So this is an additional thing. And then one other thing is that Maren pointed out that here with the naive algorithm, if you have something at 29 degrees, it's going to kind of cross the house, if you see that right here. But the way that it's generated in a lot of programs is again, this is one of those things that you wouldn't know unless you studied astrology, but it's just better if it's like fully contained in the house. So this again, I'm not trying to put Maren on the spot. She just kind of said it would look better if it was inside the house.
Yeah.
But this requires a very specific algorithm that again requires specific math, geometry, blah, 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 which I can do and I enjoy doing, but it takes a lot of time to do correctly. So that's another thing on my to-do list, and I have a good sense of how to do it, but that's one of the other like custom image rendering things that has to be done, that under any possible configuration of planets, that if something's at like 28, 29 degrees, 0, 1 degrees, we kind of push it into the planet or push it into the house to make it render.
Yeah, that's interesting. Yeah, because I know in Astro Gold it does it automatically. So I was like, interesting. Like that is not, that's another added feature. So that's cool to know that minor request aesthetically is like, that's a lot of work.
Yeah, yeah. Again, I'm not trying to put you on the spot, but it's like, you never know. Like sometimes a minor request takes like 10 minutes to do. Sometimes something that sounds simple will take literally a day to do properly. So this is also my to-do list. I have a good idea of how to do it. I haven't done it yet, but yeah, that's another example of, I think that's my last slide, but that's another example of like something that has to be custom. There has to be something like custom that's designed in case anyone has something at 29, 28 degrees, 0, 1 degrees, we have to push it inside of the house, which I'm fine with. I'm like, I think that looks better, but it's not trivial to do. So that's the
So Sasha, you just this. So this is everything you wanted to show us? I'm joking. This is amazing.
Okay. Okay. No, like again, I don't want it. Chelsea's not. I'm not. I really like Chelsea. I'm literally in her house right now. I have no like. I think she's a great coworker. But like she was writing the what are they called, the milestones for the project, and I told her, I'm like, literally doing this before even writing smart contracts, before even writing anything, this will take me 3 weeks. And like me, like I don't like being arrogant, but like your average engineer wouldn't be able to do this. Like for me, it would take me 3 weeks to write a proper image generation algorithm. So so I feel like maybe I need to start writing these presentations just to give people a sense of like what's a hard problem and what's an easy problem, because unless you've had like a lot of experience with software engineering, you won't know what's a hard problem, what's an easy problem, because something is
it's like you're trying to fix your car and be like, hey, it makes a funny noise. And then you as a mechanic understand, like, actually, no, there's a lot of fucking shit I have to do to deal with this, to fix this noise.
Yeah. I mean, it's
No,
kind
but
of.
this is up. Go ahead, Sasha. Sorry.
No, no, I agree with Choma's explanation. It's I keep going back to image stuff because I kind of studied AI in my master's, and it's just really interesting how humans are really good at understanding images. Like you can see this is off. Even when I showed you that example of like things being slightly off, humans can pick up that stuff really easily, but telling a computer how to do that stuff is like requires a lot of like the explanation, telling the computer to do that.
Honestly, as a conclusion from my side, I enjoyed this, and it was absolutely gorgeous that you showed actually how you are actually solving all this kind of stuff, especially from my side, or all of us who are not engineers. And I know to calculate 2 and 2, and that's mainly it. And then for us, it's interesting because sometimes, and especially for the future, when we will be going more deeply inside some other stuff of the project, etc., it's really important to understand actually how things work on the other side. It's I know from my experience, for example, in creative part of the process, when someone tells you, can you please just, I don't know, change this minor stuff here, and then I need to explain how you need to actually conduct 1,000 stuff just to fix this, because it's not a simple drawing. I don't know, some example. And this is the same. And absolutely wonderful. And it's more easier for us to understand for the future, for all other stuff. First of all, it's so easier to actually value the complexity of work behind, and then by understanding it, to actually know, maybe to learn something, and even for the future to speed up something, or to solve something, or to prepare something better for engineering, etc. Although I have a lot of experience, like all of us here, but still, especially for the astrology, this is first time I'm going through something like this. This is not a simple website front end. This is something different. And personally, I was enjoying, like, watching Net Geo. So for me, it was wow. And sorry, one more time, because I was late.
Yeah. I will add that I was talking to another friend that works at a software company, and they told me that they literally hire a professional mediator to deal with between product and engineering, because there's such like a disconnection between people requesting features and the complexity of the feature that they literally hired a professional mediator to go to meetings between product and engineering. So it's not unique to our company where people request things that are difficult. It's literally like software engineering in general, or like tech in general, like product requests and the actual task in terms of engineering.
Yeah, it's cool to see something that I've thought about for just years and years, how it might be done, and understand the complication of it and like how it actually all comes together for a better understanding of like future building with this, and like so that I can just, even if I'm not the one coding, like I have a good understanding of the intricacies and the specific features and what goes into all of them.
Yeah. Because it's not like, I don't even blame someone that's not an engineer and that requests features, because sometimes it's completely unintuitive. You'll ask something that sounds simple and it's really difficult, or you'll ask something that is actually simple to implement. It's like it's not intuitive if you're not an engineer, like what's a simple thing to do and what's a difficult thing to do.